All right, guys. So before we actually get started with some stuff we were talking about, there was some chat. There was some talking chat. I was gonna say there was some chat and chat. I was about to say there was some chat and chat earlier, but there was some talking chat earlier about why you should use tasks versus threads, right? And for instance, if we have a thread, right? Thread, new thread. We can give this an anonymous lambda, right? Anonymous function. What is the difference between using this? What's the difference between using this and using this, right? And this is not what we're really going to be talking about today, but it's appropriate enough. It's appropriate enough. And I'll talk about a few more things around this as well before we really get started today, right? What's the difference between using this and using this? Well, there's really only one difference between using a thread and using a task, right? A task is backed by a thread pool of real threads, right? So behind this factory is just a collection of well, they're not really pre-initialized threads. It will spin them up as they're needed if there's not enough. But ultimately, guys, this is exactly the same performance once it's warmed up, right? Tasks are backed by full-on threads. There's really no such thing as a light thread. There is the concept of coroutines in C#, and maybe we'll talk about those today. But there is threads, and tasks are just a way into the thread pool that's really always existed in .NET. They've just, in 3.0, they made it much easier to use the thread pool with the tasks, right, with the task API. So a thread and a task ultimately are the exact same thing. It's just if you create a new thread every time you want to use one, there is a lot of overhead in the initialization, the boot up time of that thread, right? Because every thread has a stack size. It has to create its context, right? So there's a lot of warm-up time, if we want to call it, around a thread. Whereas a task, once you're done using a task, there's a pool of thread objects that are just sitting idly in the background that the task factory is going to say, hey, here's one not being used. Let's just use it. Give yourself a new context, new function, new code to execute, and just execute it, right? So you save all of that cold boot time, right? So this is just a way to warm up a bunch of threads and to reuse them for whatever you want, right? So that's the only difference really between a thread, between a thread and a task. No, another Mormon. I sure hope threads are not considered advanced programming techniques. This is somebody just asked, before we get started on stuff, somebody just asked about threads, about tasks. The other question was, should you use sleep, right? Should we use sleep to communicate between threads, right? So if we use thread dot sleep, oh, I can't type. Why would you want to use this, right? What's the deal with using a thread sleep and in fun business like this? Well, whenever you use a thread sleep, guys, it's all about context switching. When you go back to the kernel, ultimately the operating system can only run one task per core. I know that's a very simplified view of what the CPU is actually doing, but we can only run one task per core at a time, right? So the OS has to time slice all of your tasks, all of your threads, appropriately. So whenever you're using a bunch of threads and you're trying to swap between a bunch of threads, and if you have more threads than you have cores, then you're going to have to start getting into what we call context switching. Context switching is very, very expensive, and context switching is basically saying I have 30 threads, I have 2 cores, I can only run 2 time slices at a time, but I have 30 time slices that need to run at a time. I have to keep switching in and out of contexts in the kernel to get between all of these threads, right? So when you do context switching, it's a very expensive operation. You want to try and keep in one context for as long as possible, right? Because if you're constantly going in and out of 30 or 100 threads in a very short amount of time, you're going to have a huge bottleneck in just context switches, right? So you want to try and reduce all of that into as few context switches as possible. So that's kind of when we talk about threading is not simple programming. Writing multi-threaded applications is not easy. That's one of the considerations you have to think about when you do multi-threaded applications. Is sure you could throw as many threads at the problem as you want. Sometimes throwing more threads reduces performance and does not increase it because of context switching, right? Somebody else asked, how do we keep threads around when they're not doing work or waiting for work to happen? And that's where somebody mentioned that you can use thread sleep. That's not the way to do it, guys. Don't use thread sleep. Use semaphores, use mutexes, right? Instead, tasks make this easy, right? Because tasks have a wait, which you can get, and they have a timeout. Or you can have a cancellation token to see if it got canceled. Use waits, guys. Use your waits, right? Use that. Because then you can use signals. You can use signals between your threads to say, hey, my thread operation is done. Let me signal that I'm done. Anybody else that's waiting on that signal, it's much more optimized than using a thread sleep. Because if you just do something like this, right, while not done. Oh, sorry, let me make this a little easier. While other thread not done, thread.sleep 10 milliseconds, right? You're now going to spin. You're going to have to context switch back into this thread every 10 milliseconds to check on if the other thread is done. This is right back to what we were talking about, right? Context switching is very expensive. Instead, the kernel gives you a much easier way to do this with using wait, right? So instead of doing this, you could rewrite this if you had a task. If you had a task, you can say task.wait. Your code will now block, just like it was in this while loop, until you get a signal from that other task that its job is done, right? And you can use signals for anything you want. They don't even have to be used in multi-threaded programming. You can use them for however you want, right? So now this will go into the kernel. It'll be flagged in the kernel. You will not context switch constantly in and out of this thread, waiting for the other thread to be done. As soon as it is done, you will get signaled into the kernel, and it'll wake this thread back up and continue on, right? So somebody who said you should use timers or you should use sleep, don't do any of that, guys. That's really, really bad. Use what's available to you. Optimize it. Okay, guys. Back to looking at chat now. Diego, what's the difference between Task Factory start new and task.run? Nothing. Nothing. Just when I usually like to hit the Task Factory because sometimes in our software development we might implement our own Task Factory. So it's always good just to have it in there in case we want to replace it. All right. My coffee's almost done again. So when would you use threads or tasks? Not Blizzard. As I said earlier, threads and tasks are exactly the same thing if you are using your own thread pool. If you just want to start up a thread to do a small block of work as a fire and forget type of operation, use a task, let it go to the default thread pool. If you're going to use a background thread to keep it alive for the entire length of your program, to do some type of weird work. Maybe you have a background render thread, maybe you have a background job reader, I don't know what it is. But if you have a background thread that's going to operate for an extremely long time or for the entire length of your program, spin up a dedicated thread for that, and that's fine. Tasks are for fire and forget, quick operations, because if you put a lot of long-running jobs as tasks into the task worker pool, you're going to tie up threads in the thread pool. Oops. Anyway, guys. Alright, that's enough talk about tasks and threads, yeah?